In this video, I'm going to discuss with you how to add and subtract radicals, and then I'm going to mix all these radical expressions up. You'll have to either add or subtract or do multiplication, and we'll try to sort things out. So let's get started. So first of all, it says adding and subtracting radicals. Like radicals have the same root and the same radicand. Remember, the radicand is just the number under the radical sign. And in the problems we're working with, we're pretty much going to just stick to square roots. Or we are going to stick to square roots. So it says, it tells you about, it shows you some like radicals and some radicals that are not like radicals. So notice here, these both have the same radicand 3 and they're both square roots. Those are like radicals. Same thing here, same thing there. So all of these have the same root. They're all, well, the first two pairs are square roots, the last one are cube roots. And they also have the same radicand, the same number under the radical sign. Look at this side over here. Notice here, whoops, these two do not have the same radicand. These two do not have the same root. Now these two, the radicand looks similar. They're certainly both square roots, but the radicands have to be exactly the same. So those are not like radicals. So same root, in our problems, square roots. And the radicand has to be the same. Number under the radicals have to be the same. All right, so that's what we're saying here. We can only add or subtract like radicals. So when we start adding and subtracting radicals, they've got to be like radicals. Now this is not really surprising. This is a common theme throughout mathematics. If you look at, for example, adding the decimal 3.17 with 145.024, we could go ahead and do that. But the thing is, when we do this kind of problem, we have to line up the decimals. Why is that? Well, that's because, for example, we're adding this 3 and 5. They're in that ones position, so we want to add our ones together. So again, we're putting the like things together. Or for example, now in the hundredths place, the 7 stands for 7 hundredths and the 2 stands for 2 hundredths because of its position. And so when we add those together, we get 9 hundredths. It's also true, for example, when we work with fractions. We need to have like fractions in order to add two fractions together. The denominators have to be the same. And so we sometimes call these like fractions. We would get 4/7 here. Or we've done a lot of combining like terms. And so these are considered like terms. We just add the numbers in front. We get 5x. And actually it says here that the way we're going to add radicals, or like radicals, is similar to how we add like terms. So in this problem here, we added the 2 and the 3, and we got 5x. So now let's look at our first problem. It says add or subtract. We've got 5 square roots of 2 plus 8 square roots of 2. And 5 plus 8 is 13. We're going to get 13 square roots of 2. So it's just as if we were adding 5x and 8x, we would get 13x. So again, all we're really doing is adding the number out front. Let's move on to the next one. So here's our like radicals. We can combine, let's see, this is going to be a 1 square root of 7 and a minus 3 square roots of 7. So we're adding 1 and negative 3. We're going to get negative 2 square roots of 7. And then don't forget about the other radical. It's not a like radical, but we do need to add it to what we already have. On number 3, we're going to add the 2 and the 8 to get 10 square roots of x. Number 4 looks more complicated, but these are like radicals. And so we can just combine 3 and a minus 1 to get 2 square roots of x minus 4. Now when you look at number 5, notice this is a radical term, and certainly 9 is not. The only thing that I can add to a 3 square root of 2 would be another radical that's got a square root of 2 in it. And so 9 is not even a radical, so we can't do anything here. Sometimes students will add the 9 and the 3, but you're combining a radical term with just a regular number, a whole number, and you can't do that. Radical can only be combined with another like radical. So this is already simplified. We can't do anything else with that. Let's go ahead and move on. Now what I've done is I've mixed up the different operations, and let's see, I would encourage you to do these problems and then come back and watch the video and let's see how you did. All right, so let's go ahead. We've discussed how when you multiply a square root times the square root of the same thing, you're just going to get the radicand back. And in fact, this is just because we're squaring a square root. And we know that squaring and taking a square root are opposites. We just get what's under the radical. Number 7, we're going to be doing combining 12 and a minus 1 to get 11. These are like radicals. We're just combining the numbers in front. Look at number 8. We have a square root of 2x plus 5, which would give us some value, and then we'd be squaring, which is the opposite thing. So basically squaring, taking a square root here, they're going to basically cancel each other out, and you're left with 2x plus 5. On number 9, it's just square root of 35. It's that simple. Whereas on number 10, it's very tempting to want to add those and get square root of 12. But the problem is we know that we can only add like radicals, and these are not like radicals, so this is simplified. Look at number 11, same kind of thing. With multiplication, I can only multiply a square root of 5 times another square root. Well, this is 4 times the square root of 5. This is simplified as far as it can be. We can't combine the 4 with the square root of 5. I can only multiply a square root of 5 times another square root. And so this is simplified as well. Number 12, these are like radicals, and we're adding. So all we're doing here is adding 1 and 1, and we have 2 square roots of x plus 3. Now number 13, I hope that when you see that, you think of FOIL. First, outer, inner, last. We've done the same thing, but we didn't have radicals. We had nice integer numbers. So we're just going to do the multiplication the way we would have before. We'll multiply our first terms, we get x squared. We'll multiply our outer terms. We're going to go ahead and put the x before the radical, so it'll be minus x times the square root of 5. And we're going to multiply the inner terms. You'll go get another x, but this time times the square root of 2. And then square root of 2 times square root of 5. Now notice it's a positive times a negative. So we're going to get a minus, and of course square root of 2 times square root of 5 is square root of 10. Now on number 14, it's really just like the one we just did. It's just we need to actually write out what x minus square root of 2 quantity squared means. It means multiply 2 of these guys. And then now we're just going to do like we did in 13. X times x is x squared. We're going to have a minus x square root of 2, another minus x square root of 2, and a plus. Now be careful, square root of 2 times square root of 2 is 2. So this will be a plus 2 since it's a negative times a negative. Now notice these two middle terms, a little tricky. We're adding a minus 1x and another minus 1x, so we're going to end up with x squared minus 2x square roots of 2 plus 2. All right, and that's it for this video.